Okay, cumulative review 3, math 3. I'm going to go through and explain some of the answers here for these practice problems. Problem number 1. Whenever you're trying to write the inverse function, what you want to do is you want to switch the x and the y. All right, so f of x is the same as saying y. So currently it says y equals x squared minus 11. You want to switch the x and the y variables, like so, and then just solve for y. Undo all of the operations to solve for y. And that's how we came up with this result, which we just changed back into the inverse function, f inverse of x. Problem 2, where does it increase? Remember, the increasing is where is the line going up from left to right. You have to move from left to right. So as I'm moving from left to right, the first time that I hit the graph, it's actually going down. Yeah, I know we see an arrow up here, but you have to be moving from left to right, and that's where it's going down. Or if you're thinking of it as a map, at what part is the graph traveling north? So first we start traveling south, then we start traveling north. So this part right here, from -1 to infinity, is where it's increasing. And then from negative infinity to the -1 is where it's decreasing. Problem 3. What is a function? Well, for every input, you have exactly one output. All right, for every input, you have exactly one output. For the graph, it would pass the vertical line test. If you were to draw a vertical line, it's only allowed to cross through the graph one time. If it hits more than once at a time, then that means that it's not a function. All right, here we have finding f of -3 and f of 2. So if I go to -3 for the x, that's right here, I want to move in either an up or down direction until I hit the graph. In this case, it's moving up. So I move up until I hit the graph, and I hit it right here at what y value? 4. So f of -3 is 4. For the f of 2, go to where x is 2. Travel up until you hit the graph. Technically, we don't hit it right here because that's an open circle. So I keep moving through the open circle until I hit this closed circle, and that means that the y value is 3. Problem 5. First thing I need to do is figure out where does -1 fit into these restrictions. Is -1 a number that's less than -3? No, you remember your negatives moving kind of backwards directions, like less than -3 would be -4, -5, -6. Does -1 fit between -3 and +2? Yes, that's where -1 fits. So that is the equation we want to use to plug in the -1. For the 4, figure out where 4 fits. 4 is a value that's greater than 2, so we use this equation. And we plug the 4 into that one. And it was asking us to subtract the 2, so once we plug this in and work it out, plug this in and work it out, we subtract those two answers, and that's how we come up with -6. Determining extraneous solutions. Now, I could go ahead and just graph this original equation in Desmos and see where the line crosses the x-axis, but that only gives you the actual solution. It does not give you the extraneous solutions. So to figure out the extraneous solution, first get it out of the absolute value function into a regular equation. And you do that by writing the original. Once you get the absolute value isolated, all right, the absolute value does have to be isolated. So for example, let's say I had a 4 out front here that was being multiplied. Then I would want to divide the 4 on both sides. Once I get the absolute value bars isolated, then I can go ahead and write the original equation without the bars. But then I want to change all the signs for every expression, or I'm sorry, for every term that's inside there. So change x to -x, change -2 to +2. And then set it equal. Don't change everything in the entire equation, just the stuff that's inside the bars. All right, change that, and then you can solve both equations. Just undo all the operations. And we got these two answers, -4 and -1. You just got to plug them back into the original equation to see which ones work out to make a true statement and which ones do not. Remember that the one that does work out, that's the solution. The one that does not work out, that's your extraneous solution.